Howdy guys, this is Carlos Bocanegra, and now we'll be going over the intermediate level functions. Here I have my main code running on my Intronic Systems workspace folder, my Engineering Learning Kit project folder. So for the intermediate functions, you can simply go to the intermediate functions header file. Here you can see that I've included all the header files for each of the sensors, as well as the I2C modules for bus 0, bus 1, our own personal Intronics header file, as well as the LED driver header file, which is an I2C device. I've also included every function that you can see, every custom function that you can see is used in the beginner level, and here you can see what is being done inside that function. As you can see here, we're using this intermediate function we created, followed by this other intermediate function. So from the main code, you can either just click on this header file and it'll open up, or you can also do a right click, open declaration, and it'll go straight to it. And lastly, you can also just do F3 and it'll go to it. From here, we can see that inside this TMP102 function, which is a beginner level function, we have two intermediate level functions being used. So we have this function, which is a USCI B0 I2C receive function. This takes the USCI bus 0 module, sets it up to I2C communications, and receives data from it. So we're getting the slave address of the temperature TMP102 sensor address when it is grounded, and we're saying we're requesting 2 bytes from it. From then, we're getting those 2 bytes and using the temperature calculations for Fahrenheit. We're putting in the data byte that we received, the first byte, followed by the second byte, which is most significant byte, and then least significant byte, calculating that, and then spitting out a Fahrenheit value. If you hover over it, you can see what's inside that function, but again, you can also just click F3 or one of the other methods to go inside that function. So back to the intermediate functions, we can go and look at each one individually. So for example, the 3-axis accelerometer has to first, and as I've stated in the comments here, so you can also read along, we set it in standby mode, set it in motion detection mode, configure it to portrait and landscape mode, set the debouncing for portrait and landscape mode, set it in active mode again, and then request data. Then we start that data at the most significant byte of the X parameter. From here we get 6 bytes of data. That is 2 bytes per each axis, so 2 for X, 2 for Y, and 2 for Z. Then that is given to the calculations function, and we're going in order of most significant bit, least significant bit, most significant bit, least significant bit, and so on. And then finally we get those data, spit out the X-axis, Y-axis, and Z-axis. This sensor is the first sensor that uses LEDs, so we also have an LED function being used. Here we have the limits2 function, which takes the 3 variables that we're getting and compares it to a positive limit, a negative limit, and then it tells what LED to turn on and at what LED group to turn on, and then what specific LED to turn on in that group. Next, we'll go into the humidity and temperature, ambient temperature sensor. Here we're transmitting 1 byte first, setting it to humidity hold mode, then receiving 2 bytes of information, which are the humidity data, then calculating taking those 2 bytes and calculating the humidity in a percentage. Then we're doing the same thing, except setting it to temperature hold mode, again getting 2 bytes and calculating the Fahrenheit ambient temperature. We then set the LED limits, this is just LED limits as opposed to LED limits 2. The difference between them is that this one takes a variable that you give it, in this case humidity, takes an upper limit and a lower limit, and then sets the according LED turned on. The same thing is done for the ambient temperature. The limits are done detailed here. So for example, if you want to change the limit from 85, the upper limit of the temperature to be 90, you simply just click 9. Oops, you click 90 right there, and that's it. Okay, next we move into the light sensor. From here we see, again, we're first, put my comments here because it was a little bit long, but basically what you're doing in this function is you're setting it to automatics full scale mode and setting it to continuous conversion mode, as well as setting the latch field on. You can see the datasheet for more information on this, but that is what's being done here. Then you're telling the device that you will be reading from the result register. Finally started reading 2 bytes at a time, and then calculating the lux value from those 2 bytes received. This time we're using the LED bright function. In this case, it takes a upper limit and a lower limit, and it lights just one LED, but it shines that LED brighter if it's below this limit, the lower limit, it will turn it completely off. If it's between the lower limit and the higher limit, it'll shine it at around 20% brightness, and if it's above the higher limit, it'll shine around 50% brightness. So if you want to use this function with another variable, you can easily do that. Finally, let's go into the motion sensor function. All we have is a digital pin. So we have our motion detection function and then simply our LED on off function. This function, what it does is it gets data from the motion data from this function. It sets a limit, and then if the value is greater than 5, meaning motion was detected, then it turns this LED on. If the value detected was less than 5 or 5, then it turns this LED off. Simple on and off. I left this as in hex just to show that this, for example, PWM3 is the same as saying OX05, so this would be the same as saying PWM8, I believe. That's just to show that you can do both ways. Finally, we have our Intronix communications function, and this is just down here in the same main C file. Sorry. From here, we check the ID that we received and check if it's equal to the ID of this specific node. If it is, then we transmit an acknowledgement, wait 10,000 clock cycles, and then set up our packet in the order that we have it. This is our specific order that Intronix Systems decided to use. It is detailed in documentation, and you can change it to whatever you want it to be. This function does transmit 20 bytes, while ours only has 19, hence there is a no character. After we set up the packet, we transmit that packet, and we put 20 here because that is the amount of bytes we're transmitting, although again, the 20th character is an O character. If the ID does not match your ID of this node, then no operation is done, which means nothing happens. It goes back to here, goes on to the next step. This while loop is done. It checks the condition is still 1, so it repeats. And this allows us to keep repeating basically indefinitely until the battery dies. That is a basic overview of the intermediate functions. If you want to create your own functions, let's say you have another sensor, you can easily go to intermediate functions and header file and see how these functions were made, as well as look in documentation to see all the functions that were made. And you can just simply create a function, for example, for another sensor, and just start using these in the order that sensor requires, which can be found in the datasheet. Most sensors will require you to transmit some sort of information first to them, which will allow you to set them up in the correct mode. Then it will ask one last transmission of telling it what you want to read from, then reading from it, and then using math to calculate it. That is essentially the intermediate level functions. Again, my name is Carlos Bocanegra, and thank you for listening.